Hello and welcome to section 4.5, Factoring Polynomials. So today we're going to kind of focus on some of the special patterns for factoring. We are also going to look at some factoring by grouping, but the focus for the majority of it is going to be on those special patterns, which you really should memorize. So they are listed below here on the page. The factoring perfect square trinomials, the difference of squares, sums of cubes, and the difference of cubes. So yes, as it says, you need to memorize these, okay, if you haven't already. So if you need to, you can go ahead and pause this so you can write those down. Okay, those are super important. Okay, now when we actually are factoring something, the first and foremost thing we want to do is look and see if there are any common factors that we can take out. If there are, we want to make sure we take out the greatest common factor. Okay, that will make the rest of our life so much easier, or at least the rest of this problem. Okay, so much easier if you factor those out first. Okay, then we're going to look for special patterns. Does it fit one of those patterns that we just mentioned? Okay, and then last but not least, if we can't do that, okay, can we use grouping? Now, just a little hint, okay, in the ones we're doing today, most of the time, if there are 4 of them, that means you're probably going to be factoring by grouping. Okay, if there are 2 or 3 of them, hopefully that means you can figure out what that special pattern is that exists. So, our examples. Okay, step number 1 here. We have x squared plus 14x plus 49. So first and foremost, we ask ourselves, is there anything I can factor out of all of these? The answer is no. Okay, so then I have to say, does this fit a pattern? Well, it very well may fit a pattern, right? Because we have a perfect square plus a number plus another perfect square. So, right, if we take the square root of this, it gives us x. If we take the square root of that, it gives us 7. So we know that if this does fit the pattern, then this would be 2 times a times b, right? Where the square root is a and the square root of this one is b. So we have 2 times 7 would give us 14 times x gives us that 14x. So that means that this is a perfect square trinomial. So this then would just equal x plus 7 squared. Okay, for our next one, we again look, is there anything that we can factor out of both 81 and 4, and the 4a squared? And the answer is no, there's nothing we can. Right, but this is a perfect square, right? Square root of 81 is 9. The square root of 4a squared is 2a. So we have those 2 perfect squares being subtracted. So that's the difference of squares. So that means that we can use that, which if we flip back over and look, if you need to, okay, right, our difference of squares is a plus b times a minus b. So that means that this is going to be 9 minus 2a times 9 plus 2a. Right, and remember, you can switch the order of those. You could have 9 plus 2a times 9 minus 2a. And because of the commutative property of multiplication, we know that those are both congruent to each other. Okay, for number 3, we hopefully notice right away they both have 5 and they both have a, which means we can take a 5a out. And then we can just focus on what's left on the inside. Okay, so we have to have that 1 there, right, to hold the place, so we multiply it back out. Now remember, 1 is a perfect square, perfect cube, it's a perfect everything, right? So you multiply 1 by itself as many times as you want, and you're always going to get 1. Okay, so that means this right here is, right, the difference of cubes. So carry over your 5a, and then we go to the difference of cubes. So this is going to be our first term, right, the cubed root, which is a, minus 1, times the first term squared, which is going to be a squared, plus a times b, which would just be the first term times the second term, which is a times 1, which is a, and then plus, okay, our b squared, or our second term squared, which 1 times 1 is just 1. So our final answer is this whole thing, 5a times a minus 1 times a squared plus a plus 1. Okay, on number 4, we want to factor out a b, because we can see a b in each one of these. So this is b times b squared minus 10b plus 25. Okay, hopefully you guys recognize then that we have b squared, which is a perfect square because the square root is b, and 25 is a perfect square because its square root is 5. Okay, so this again is one of those perfect square trinomials, and since we're minus plus, that means it has to be a minus when we go over. So this is b times b minus 5 squared. Okay, number 5, there's nothing we can factor out of all of it. It has 4 parts, which means we doesn't fit any of our special patterns. So that's when we try factoring by grouping. So I start off by saying try 1 and 2 together, and then the 3rd and the 4th together. If that doesn't work, you could always rearrange them. Try 1 and 3 together, and 2 and 4. And then finally, you could try terms 1 and 4 with 2 and 3 to see if there's anything that you can factor out. So here out of xy plus 3y, I could factor y out of both of those, which would be an x plus 3. And then for the second one, okay, I can take a 2 out of both of those, and that would also leave me with an x plus 3. So now, right, we have y times x plus 3, and we have 2 times x plus 3. So we can just simply write that as y plus 2. So I just take this and bring them together. Okay, and then multiply it by x plus 3, right? Because mathematically that's the same, right? Is y times x and y times 3, which I have right here, plus my 2 times x and my 2 times 3, which is what I have right here. So this is how we factor that down. Okay, number 6 is a similar type of problem, right? There's nothing we can pull out of it all, so let's try breaking it in half. We could take a 5q out, and we're left with a 2q minus 1. And then on the second one, we can take a t out, so that would mean we have 2q minus 1. So again, our insides are the same, so we can bring these outside pieces together. So 5q plus t times 2q minus 1. Okay, on to number 7. We have a perfect square here, and the square root of that would be 4s squared, and then 1 is always, right? Perfect, we talked about that. So that means we can write this, okay, as that, right, difference of perfect squares. So that's 4s squared plus 1 times 4s squared minus 1. Okay, but here we have to be a little careful, right? Because 4s squared is also a perfect square, and 1 is also a perfect square, which means we can do it again because we can take the square root and get 2s and take the square root and get 1. So we actually have to do 2 parts to factoring this problem. So that means that this is going to be the 4s squared plus 1. We can't do anything with it, right? It just comes over. And then we break this down, and this is now 2s plus 1 times 2s minus 1. Okay, on to question number 8. Here we have to say, well, can I factor anything out of this? Well, yup, I can take a 2 and a u out of each part of this, which leaves me with u cubed plus 27. Okay, so if I have u cubed plus 27, hopefully you guys recognize that that's the sum of cubes. So then I can just simply carry my 2u over, and now I just turn this into following, right, my sum of cubes. So this is my first term u, right, because the cube root of this is u, the cube root of this is 3. So this is going to be u plus 3 times u squared minus, right, a times b. So a times b would be u times 3, or 3u, and then plus our b squared, so 3 squared, which is 9. And then we look at that and we can say, okay, that's a perfect square, that's a perfect square, but this we can't get, right? We can't go from minus to plus, okay, with perfect squares. So then we go on and we look at number 9. So number 9, again, this one's a little trickier. You just have to remember anything raised to an even exponent is actually a perfect square, because we can always break it down into the 2 equal pieces. So if we break this down into equal pieces, right, the square root of 4 is 2, and then m to the 8th, we break it into the 2 even pieces of the 4th, and then that gives me my perfect square. Same thing over here, we take the square root of 9, and that gives us 3. And then here we just break this into 2 even pieces, so p to the 3rd. So now we have a minus here, the plus here. Well, if we do 2 times 2, that's 4, times 3 is 12, so that gives us the 12 we need, and then we have our m to the 4th, p to the 3rd. So that means that this is just simply 2m to the 4th minus 3p to the 3rd squared. So the biggest thing here is just recognizing those patterns. So again, take your time, memorize those patterns, okay? And this is our assignment for tonight. We're going to take a quiz in class tomorrow. You can use the formulas on. Then we're going to do these for homework, and then the following day we'll take a quiz where you can't. Okay, so first day you get the patterns. Second day they have to be memorized, okay, or else you'll get them wrong. So hopefully you have a great night, and hopefully this was helpful. Thanks a lot, guys.